writing something on the board. Okay. So if you have question, you can ask. Otherwise, I will discuss. Not otherwise, I will discuss. There are something I need to discuss already in this chapter. So not big things, not many things, some little things, but important. Okay. So let me just discuss first. Then I will ask you if you have any question. Is that okay?
Yes, sir.
Okay. So I told you already one type of relation is called equivalence relation. Let me write it by typing. That will be better. Okay. One is called equivalence relation, and equivalence relation is a type, and this type of relation will be reflexive, symmetric, and also transitive. I told you already, right? So this is one type of relation. And whenever you have a relation, you will check whether it is reflexive or symmetric or transitive or not. If you see everything is yes, then it will be uh, equivalence relation. So if there is something missing, okay, maybe not reflexive, you need another one, then it will be uh, reflexive. Otherwise, you cannot say this is reflexive. You understand what I'm saying? Sometimes it may happen you have a relation and you are checking the properties and you see it is not exactly reflexive because something is missing, maybe, right? So say the original set is A and you have some numbers, say 1, 2, 3, 4. Okay, these are the numbers. Now you need to have 1, 1 and also 2, 2 and 3, 3 and 4, 4. You need to have everything. So that will be reflexive. If 2, 1, 1 and 2, 2 are present, but 3, 3 and 4, 4 are not present, then it is not reflexive. So what are the missing things so that it will be reflexive? You can say in this case 1, 1 and 2, 2 are already there, so fine, but we need 3, 3 and 4, 4 also, because these are needed for being reflexive relation. So original relation is R1 and there are many different pairs, and 3, 3, 4, 4 are not inside R1. So we need 3, 3, 4, 4. This is another set which needs to be included in the relation so that we can tell this is reflexive. So if there is something which is missing, which needed to be included, that is called closure. That part, that set which is necessary, that is called closure. You understand what I am saying?
Yes, sir.
So it is called closure, sorry, CLOS SURE. Okay, that is called closure. So if it is about reflexive property, then it will be called reflexive closure. So now try to understand what about the symmetric closure and what about the transitive closure. Is that clear? Reflexive closure. Is the idea clear? Now think again and try to understand. Do you understand what I say? So what is the closure? You will tell closure is the set of elements which is necessary to be in the relation for completing a property, for completing a certain property. I'm telling again. So what is the closure? Closure is the necessary pairs. Closure is not one single pair. Closure is the set of all necessary pairs or the elements so that certain property will be completed. So in this example, 3344 set of these two items will be called reflexive closure because in the original relation other members are present but 3344 are missing. So this part is called reflexive closure. Is it okay now?
Yes, sir.
Yes, sir.
So if I think about, say, 2, 3 is one pair already there, and the opposite of this 3, 2, that is also included. Say another pair is 1, 4, but opposite of this 4, 1 is not present. So what you can call the symmetric closure? What will be the symmetric closure? So you will tell symmetric closure of R1. What will be the symmetric closure of R1? Yes, tell me. Somebody is saying something or not? What will be the symmetric closure of R1?
4-1.
4, 1 and anything else? 4, 1 is correct. And anything else? Not really. Why not? Can you say 3, 4 also necessary? Can you say like that? 3, 4 is also necessary. Can you say like that? No. Why not? Because if 4, 3 is included already, then you need the opposite one. Otherwise, you do not need 3, 4. So 4, 3 is also not present. 3, 4 is not necessary. Then fine. 1, 4 is there. Opposite of that 4, 1 is necessary. Only the necessary items will be in the closure. That's all. So you now understand the transitive closure also.
Yes, sir.
So what will be the transitive closure in this example? I am not changing anything. Just 1, 1, 2, 3, 3, 2, 2, 2, 1, 4. These are the elements, and that's all. I'm not including any more. I'm just saying what will be the transitive closure. Now tell me, what will be the transitive closure? Any idea? In this example, think and find out transitive closure of R1. No idea? Try to tell something. What will be the transitive closure of R1 that is necessary for being transitive? Otherwise, it is not transitive. If you include something, then it will be transitive. So, what is that? Is there anything?
Sir, 1-4.
Hello, sir.
Oh, 1-4. Yes, 1-4 is already here. Yes, yes. Tell me.
Sir, actually, I have another class, and there is I'm giving class test. Me, Sani Akhtar, and Afia. Sir, what should we do?
No, no, of course, you will do the regular class and give exam class test also. About this, I have told you already. I am already recording, so you will watch the recorded video later. Okay, so it's
Sir,
okay.
what
You
about
can.
the present?
Present is already given.
Sir, should I
What is
give
your
material
name?
now? Sir, Mehdi Islam.
Mehdi Islam. I will give you presents, no problem. Okay.
Okay, sir. Okay, sir. Assalamu alaikum.
Okay. So tell me what is the transitive closure in this example?
Sir.
Yes.
So actually, I have no clear concept about transitive property. That's why it's confused.
Okay, no problem. So let us discuss about this first. First of all, you need to check whether this relation is already transitive or not. If it is already transitive, then you do not need anything else, right? Then you will say no, nothing more necessary, so closure is null, closure is blank. You understand? If you say that this is not transitive, then you will check how it can be transitive. So let us check whether it is transitive or not. So how you can check whether it is transitive or not? You will check two items, serial two items first. Okay. So what are the two items? Say one is 2 3 and then another is 3 2. So serial means what? 2 3 then 3 to another thing. So 2 3 3 2. It is like A B and B C. So what will be the third element? What will be the third item?
AC.
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 So you will check in this case, you will check what? 2, 2. In this case, what will be the third item? 2, 2. So do you have 2, 2?
Yes,
Yes.
sir.
Yes. It is already there. So 2, 2 is fine. Now, if you consider 3, 2 is the first item, if you consider 3, 2 is first, say I am writing here 3, 2 is my number one pair and second pair is 2 3, then what will happen? Is it serial or not serial? This is also serial. 3 2 then 2 3. So what will be the third item? What should be the third item?
3,
3, 3. The third item should be 3, 3. So do you have 3, 3? No. In this case, 3, 3 is not included. So we need 3, 3. We need 3, 3. Otherwise, it is not transitive. Okay. Now check with other pairs. Check with others. Say one is 1, 4. Another one is 1, 1. Now think about this. If 1, 1 is the first pair and 1, 4 is the second pair, 1, 1, 1, 4. What will be the third pair? Third pair is 1, 4. So is it included? Yes, yes, it is included. This is 1, 4, isn't it? So fine. If you consider 1, 4 is the first one, then 4 something? No, not. Okay. Then any pair, any else pair do you have? Check. Serial pair, anything else? Do you have similar pair like AB and BC? Do you have any other two pairs like this?
Sir, 2, 2, 2, 3.
2, 2, 2, 3. Yes, yes, you are right. So 2, 2, then second pair is 2, 3. Then what will be the third pair? 2, 3.
2, 3.
2, 3 is already here. So no problem, it is here. You understand? So actually all other necessary things are present. Only 3, 3 is needed to be transitive. If you have 3, 3 in this relation, then you can say this is a transitive relation. So we will check what is missing for being transitive. So if you can find out something which will be included and the relation will be transitive, that will be called the closure. That's all. Is that okay? Do you understand now? Is this clear? The idea is clear.
yes, sir.
Okay, so that was the other thing I wanted to tell, and let me tell you the other name of relation. Another type of relation is called partial ordering. Okay, partial ordering is another type of relation, and this type of relation is reflexive antisymmetric. This type of relation is reflexive, uh, antisymmetric, and transitive. So this is another type. And the closure concept is all the same for everything. So other type of relation can be there, which is just other type. There is no name. Okay, another type. Not equivalence, not partial ordering, just normal kind of relation. So now I give example of a criteria which is uh, for equivalence relation maybe. So one term is used sometimes. It is called congruent. Okay, congruent, say modulo 3 or 4. Okay, whatever. So what is the concept of congruent modulo 4 or 3? The concept is uh, try to understand modulo 4. Modulo 4 means mod 4. You already know what is mod 4. So it should not be a big problem. You already know what is mod, right? Say, let me give you example. Say 5 mod 4. What will be the answer? Mod 4 means modulo 4. So 5 mod 4. What will be the answer? What is 5 mod 4?
So 1.
5 mod 4, 1. Okay. So what will be 9 mod 4? What will be 9 mod 4?
2.
2? No. Check it again. Calculate and give me the answer. Mod? How can you find out the mod? You divide 9 by 4 and then you get the remainder. Mod
1,
4,
sir.
4, it is 1. Correct. So what will be 17 mod 4?
It also 1, sir.
It is also 1. Good. So what you see, every time you are getting the same answer. Mod 4, the number is different, but mod 4 is giving you the same answer. So if the mod 4 giving you the same answer, then we will say 5 and 9 and 17, these are the congruent mod 4 numbers. These are the congruent numbers. So you can say 5 is congruent. Okay, you can say congruent. 5 is congruent mod or modulo. Modulo is the original word. Mod is short form. Congruent mod 4 to 9. Or you can say 5 is congruent modulo 4 to 17. So this is the concept. Is that okay? Do you understand? So if I write 6 mod 4, then what will be the answer?
2.
6 mod 4 is 2. So if you think about 10 mod 4, that will be also 2, right? So you can say 6 and 10. These are the congruent mod 4 numbers. Is that okay? Do you understand now? 6 and 4 also congruent mod 4 number because they give you same answer. Is that clear or not?
Yes, sir.
Okay. Now I am writing something. Okay, check it again. Say I'm writing R is a relation on the set of integers. Okay, that means, okay, let me write natural numbers. Okay, negative we are not taking. Set of natural numbers. Okay, R is a relation on the set of natural numbers. That means all whole number and positive. Okay, uh, based on the criteria congruent modulo 3. Okay, congruent modulo 3 prove that R is an equivalence relation? This is the question. So how can you prove that? You will check the properties, right? So what are the properties? Reflexive, symmetric, transitive. All three properties should be satisfied. Then it will be equivalence relation, right? So how can you check, how can you tell about the separate pairs? Can you find out or can you write down all the pairs with all the integer numbers? Is it possible? Because there are many millions, billions numbers. So how can you talk about this? What is the original set here? What is the domain? Set of natural number is the domain. You understand? So what is the domain name? N. And who are the numbers in that? 1, 2, 3, 4 and unlimited. Okay, there are many numbers. So it is not possible to write down all the members of n cross n. Not possible. It is not possible to write down all the members in R. R is the relation. And who will be the members? Tell me, who will be the members? I have already told you it is not possible to write down everything, but tell me some examples. At least tell me about 2, 3, 4 examples. Who will be the members in that relation? What comma what you can take? So you will try to find out congruent modulo 3 in this case. These are the examples of congruent modulo 4. So if you think about congruent modulo 4, you will write 5, 9. Why? Because 5 is a congruent modulo 4 to 9. So it is included. You can write 5, 17. You can write 9, 17. You can write 6, 10. Why 6, 10? Because 6 and 10 are congruent and it is modulo 4 congruent. So now we are thinking about modulo 3 congruent. So what you can take, what you can write here? Any idea?
Sir, 4 and 7.
Yeah, you are right. So you can write 4, 7. This is correct. This is one example. So you can also write 7, 4. That is also possible. Okay, 7, 4. 4 is congruent to 7 and at the same time 7 is congruent to 4 because they will give you the same answer if you do modulo 3. So you can also write 1, 4. You can also write 4, 1. You can also write many different examples. You can also write 1, 10. You can also write 4, 10. You can also write 4, 16. Is that okay? Do you understand? Do you understand me now?
Yes, sir.
So there may be hundreds of thousands of millions of numbers. So it is not possible to write down all the numbers. Just try to understand and try to find out, is it equivalence relation? Is it reflexive? Is it symmetric? Is it transitive? That is my point. Is it okay? So if you cannot solve this now, if you cannot do this in 5 minutes time, that is also all right, no problem, don't worry. I will not give this question in the exam, because this type of question you need to think, you need to get into the topic, you need to logically understand. Okay, I will give you some questions so that you can find out the list. You can write down the list clearly. Maybe there will be 5 items or 6 items or 10 items like that. But if you cannot write down all the things, because it is a very, very big set of numbers. So in that case, you will write your answer logically. Okay. So that type of question I will not give in the exam, because it will take longer time. You need to think for a long time. So it's not possible to answer within time. Okay. So what is the final exam timing? Do you have the routine already? What is the final exam time? How long?
21 September.
Yes, but duration of the exam. What is the timing?
Sir, 1 and 30 minutes.
1 hour 30
1 hour
minutes.
30 minutes.
Okay. So it is not very long, right? So if I give you this type of question, then it will be very hard to answer. So don't worry about that. I'm just showing you one example. This is one example with set of natural number. So this is not a good idea for exam question paper. But if I give you some specific number, say 1, 2, 3, 4, 5, then fine, then you can find out easily, right? So don't worry about this. Try to understand the properties and try to understand how to answer. If I give you this question with a small set, say A is the set and it is 1, 2, 3, 4, 5, then how can you answer? There will be only limited numbers. In this case, it is not very tough. It will be very easy to understand. Okay, and write down. Is that all right? Any particular question? So that is all from the chapter actually. I wanted to tell up to this, and the relation chapter is finished, and that is all from my side. If you have any question, you can ask. Any question? No, right? No more questions. So let me stop recording here.